Okay, so parabolas. Okay, so the other day we did translation. Okay, so we did the horizontal.
I'm not writing that yet.
Horizontal translation, and then we did the vertical translation, and then we talk about the dilation. Okay, so we did dilation, and then at the end we finish with reflection. Okay, so that's what we did the other day. For example, okay, sketch the following. Number 1 or A. Okay, let's say that we are going to sketch this parabola.
Can you just give me a second?
And what we are going to do, we are going to sketch each one of these parabola, and we're going to compare them with the y equal x squared. So on the same number plane, we're going to graph y equal x squared, and then a, and then in a different number plane, b, c, d, and e. But in all cases, we're going to draw the y equal x squared, okay? Because I really want you to remember the effect of doing translation, dilation, and all that sort of thing. Okay, so solution. Okay, so the other day we say that, the y equal x squared, which is, the normal, the easy one, looks like this. Okay, so that is y equal x squared. And then we say that the effect of adding 2 to it is just move the parabola 2 units up. Okay, so that means that we're going to have exactly the same shape. Okay, so we're going to have the same thing, but 2 units up. Okay, so that is equal to y equal x squared plus 2. Okay, so we know that, right? B. Okay, so if we take away 1, the picture, the shape won't change, but the position will change. Okay. And we call this variable translation, okay? So variable because it will translate along, the axis of symmetry, okay? And then we talk about left and right, okay? So horizontal translation. So we're going to do exact same. So we're going to draw the y equal x squared. And then we said that the effect of adding 3 inside the bracket, do you remember what happened? Yes. Move the picture to the left. Okay, so how many units? Exactly 3 units, right? Okay, thank you. Alright, so if you add 3, then the picture will move exactly in the opposite direction. It will move to the left. Okay, so if you take away, then you know what happened. It will move to the right. Okay, so that is the answer for C. Then for D. Okay, so we have y equal x squared. And then we said that the effect of taking away 1 inside the bracket and adding 3 out. Do you remember what happened? That's it. So it's going to go 1 across and 3 up. Okay, so this is 1. So let's say that this is 1, 2, and 3. And this will mean that the vertex is going to be here now. Right? Do you remember that? Okay, that's good. And question E. Okay, so when we have a number in front of the x squared compared to the original one, all what we're doing is making the parabola. Now you're going to tell me it gets wider or thinner? I always say, please think before you open your mouth. I guess some people do things the other way around, open the mouth, and then, oops, think. Doesn't work like that. So anyway, okay, so here, and this is how you do it. So please pay attention because this is how you do it. So if you want to do a rough copy of this, okay, so if you want to do a rough copy of this from here, this is how you do it. So you pick a point in here, you pick any point, let's say that is a point, say something, 2, it's not to escape, obviously. You're going to go like this, and then you're going to go across. And then the new one is double that distance. Okay, so that means that you're going to go in here. So you're going to go up to here. Okay, so let's say that this is 4, then you go up to A, and then you go across. And then you're going up from here. That's where the other point is going through. Okay, so that means that, I said it again. You pick any point along the x-axis, and then you find the y value. So you go here, and then you find the y value. Okay, let's say that the answer in this case equals 4. Okay, so that when x equals 2, then what is the answer for y? So it's going to be 2 squared, which is 4, right? Okay, so you're going to put 4 there. It's not to scale. And because this is double, okay, so then that means that the value for the new one, which is thinner, it grows quicker. How quicker? Twice as much as the other one. So I mean that this is going to be 8. Okay, so you go from here, you double whatever that distance is, you double it, and then you come across, and then you draw the line. That is where the parabola is going. So I mean that you can have an impression of what is going on. Okay, and then on the other side you do exactly the same, obviously. Right. So I mean that is the picture. Well, you're going to have to try harder. If you don't get it, think about it. Okay, that's how you learn things. Alright, so that is the dilation. And if I put half in here, what's going to happen? So it's going to be half. Okay, so that means that it should be somewhere here. So and then obviously it gets, further. Yeah. Okay, and then I'm going to put one more in that list. I'm going to put I'm going to do it in here. So I'm going to put question F. Okay, please do question F. Y equals negative x squared. Okay, so we're going to do that again. So you're going to put another one on that list. Okay, so here we have, an example of all possible transformation except rotation. Okay, we don't do rotation, we do just vertical, horizontal, and then we do dilation and reflection, yes.
I'm just wondering how reflection works, because if you don't, when you square a negative number, doesn't it turn to a positive?
Yeah, but you have the negative in front of the x square. You see? So you got to remember that minus x squared is not equal to minus x squared like that. So that was a very intelligent question. Thank you. Right. Okay, so can you please copy all this, and then we're going to move on to something that we call the turning point form. Turning point form of parabolas. That's going to be the heading. Okay, so you're going to write it down here. Okay, so that's what we did the other day, right? Okay, so that is what we did on Friday. Okay, now, turning point form of a parabola.
Parabola. Just parabola. Parabola.
Okay, consider, that parabola. Okay, consider the parabola y equals x squared plus 6x plus 2. If the equation of a parabola is given like this, we find that is given in the general form. Okay, so we're going to put this general form. General form. But I really want to express this parabola in this form. Okay, so I really want to go from here to here. And this is the turning point form. Okay, so I want to go from here to here. And the reason why I really want to do so, because if I do that, then I can very, very clearly see what the vertex is. Okay, I can spot the vertex straight away, and also I can see the y-intercept when you multiply this, and it's easier for graphing. But to do that, we're going to have to do something that we did in the past, which was completing the square. And do you remember completing the square? Okay, so we're going to do one or two equation, and then we're going to see how we can apply that to go from here to here. Okay, so we're going to say review. So the subheading is review of completing the square method. Okay, so I'm going to say review of completing the square method to solve quadratic equation. All right, so here we go. So let's say that you really want to find the answer for this. X squared plus 9x plus or minus 7 equals 0. Okay, let's say that we're going to find the answer for that equation, but we're going to do it by completing the square. And this is a monic. Do you remember that we made the distinction between monic and non-monic? Do you remember that monic means 1 in front of the x squared, non-monic means any other number in front of the x squared but 1, all right? Okay. Do you remember what we used to do? And if you don't, well, I'm going to show you again. So if you are completing the square, what do you do first? Yes. That's it. Okay, so we can move the constant to the other side. Okay, so we move the constant to the other side. And we normally do this together with the formula. It's when we cannot find two numbers that when you add them together equal all that business, all right? Okay, and then we divide 9 by 2. So we put x plus 9 onto the square. Put 7 here. But then we need to add the square of 9 on 2. Yeah. Yeah. Again, then we put 9 on 2 square. Okay, so it's going to be 81 on 4. 81 on 4. Right? That was the way. Okay, so we divide this by 2, and we put it in bracket like this. So we say x plus 9 on 2 close bracket square. And when you do this, this expression compare with that one, well, this is going to be is going to have an extra 81 over 4. That's why we have to put 81 over 4 on the other side to keep the balance. Okay, and then I remember you adding these two. Okay, so we do all this in isolation. Okay, so can you please add these two things? 7 plus 81 over 4. Can you please do that? 7 plus 81 over 4, and give me the answer as a fraction. What is it? 109 on 4? All right, so we got 109 on 4. And then, do you remember the next step? Yeah, so we square. So that will give you, when you square, then you're going to have x plus 9 on 2 is equal to plus or minus. Do you remember the plus or minus? Yeah. Okay, and then we can find the square root of 4, but we cannot find, a whole number for 109. So we do the square root of 109 divided by 2. All right, because the square root of 4 is 2. Do you remember that? Okay, we did a lot of this. Okay, and then we have x is equal to, and then we move this plus 9 and 2 over the other side, and because these two have the same denominator, then what I'm going to do is just going to put minus 9 plus or minus the square root of 109 divided by 2. Okay, and then that's how we find the solution. Okay, and we call that completing the square because that is exactly what you do. So in here, there is something missing to have the full square, and what is something missing, or what is missing is this number. Okay, this compared to this is that number is missing. That's why we do it this way. All right, but anyway, we do some question like that. Do you remember ever doing this? Yeah. Yes, and we did a lot. Sorry? You do 9 over 2.
Just do it.
That's how it works. Always you divide this number by 2. Whatever that number in front of the x, yeah, that was the message.
Okay.
So you divide whatever the number in front of the x by 2. That's the rule.
Could you put, if it was say like 6, could you put 3 there instead of?
Yes. So if this number was divisible by 2, then obviously you put the answer. Yeah. Yes. Okay. Now we're going to see how these connect to what we're doing now. Okay. Now we're going to see how we're going to change this equation to this form. Okay. Now you need to pay attention. All right. Okay, how to apply the completing the square to sketching. Okay, so how to apply the completing the square to sketching. All right. So this is the equation, x squared plus 6x plus 2. And I really want to modify this until I have something like that, right? Because if I have something like that, then I can easily graph it. Okay, and this is how I do it. This is not an equation anymore, okay? So this is not an equation, so we're not going to be doing exactly the same. So we're not going to find x, all right? So in here we find x because this was an equation, but in here we're just going to manipulate that expression until it looks something like that. All right, so this is how you do it. So we're going to put the x squared, or we're going to do it in one go. So I'm going to put x and then plus 6 divided by 2 is equal to 3. Okay, so we're going to do 3 square. And then plus 2, but then we need to add 9. Okay, so we need to add 9. Okay, because we need to, actually we need to take away, in this case, sorry. We need to take away the 9. And then we're going to simplify. So 2 minus 9 is equal to, what is it? Negative 7. Now, can you please expand and simplify, and you will see that you're going to get exactly the same answer as on top in here. Can you please do it on a piece of paper, do it in, somewhere in your book. Do this. So do the expansion of this, take away 7, simplify, and then you're going to see that you're going to end up having exactly the same expression in there. Can you please do that?
Where do we get the negative 9?
Just square up.
Why?
It's like in the other equation, you know how you like, the third step over there, you have the 81 plus 4. It's just 6 on 2 squared, which is just normal.
Ah.
Oh. It's okay if you don't understand. Mathematics, yeah.
Okay, what happened to this actually? What happened to this?
So it's kind of like the other one, but instead of the equal, there's the plus there.
Yes, sort of. What happened to this? Let me answer your question. If you go from here to here, we're doing this, okay? But if you do this, you're going to be adding an extra 9 to that expression.
Yeah.
Okay, that's why to compensate that, we need to take that 9. So what you're actually doing is adding 9 and take away 9. So that means that the expression stays the same. Okay, but we are doing in a very particular way, so then you can see this square minus 7. That's what I said. Can you please do this? Okay, let's go. We're going to do this. Notice. Okay, so keep with that. Notice x plus 3 is squared minus 7. So we're going to expand and simplify. All right. Tell me what to do. So yeah, what is the answer for this? Remember?
X squared plus 6x plus 9 take away 7.
Yeah.
Yes. That's what I got.
All right, now if you simplify this, that is going to be equal to 2, which is the original expression. Can you see that? Yeah. So in here, all what we're doing is adding this 9, but if you do that, then you have to take away, so we compensate. It's like adding 0 to the expression. Anyway, so that was a simple one. Let's do another one until you fully understand what is going on. 2. Let's say that I really want to change this x squared plus 10x minus 4. Let's say that I really want to change that to the turning point form. Okay, so this is the turning point form and this is the general form. Okay, so we went from general to turning point. Okay, can you please have a go and see if you can do this one by yourself? Have a go. Okay. So you're going to be reasoning in the same way. Okay, so this is humanly possible. Okay, it's not like, oh yeah, no, I don't know how to do it. No. Okay, so this is humanly possible. So any human being in year 10, 5.3 should be able to understand what to do. Because it requires 2 steps. That's all it requires, 2 steps. And it's done. And I'm going to help a little bit. Step number 1, open the bracket. That is a good and valuable help. And then I'm going to help you a little bit more. So you're going to put x. That's how you do it every time. Open bracket, x. That's how you start. Mim, you got it? And then I'm going to help you a little bit more. So what's the answer for 10 divided by 2?
5.
That's it. Close bracket. And then what is the square of 5?
25.
And then you say 4. That's it. That's all you do. What can be easier than that? All right.
What is it?
Yeah.
Yeah, come on.
And then it's going to be and then it's going to be minus 29. All right. Okay. Right. If you look at this equation, like that, it's no way that you're going to tell me where the vertex is in one go or straight away. So if I have the equation like this, no way that you're going to say, oh yeah, the vertex is, no. Okay, but if I go from here to here, then you can tell me now where the vertex is. Alright, can you tell me where the vertex for that parabola would be?
Minus 29.
Minus 4.
Minus 4.
What is the vertex for this parabola?
Minus 5,
Negative 29, negative 5.
Right. Okay, so can you please...
Let's think before we say. Let's have a go.
Negative 5, negative 29. Negative 5, come on, negative 5.
Yeah.
It's negative 5.
So it goes across.
Alright. Okay, so get your laptop. Please, laptop. Get your laptop now.
Goes down to the line.
And then you're going to be using GeoGebra. And what you're going to do, pay attention, you're going to graph that one, so you're going to put that in your input line, and then you're going to do the same with that one. And let's see if you get the same picture. Okay, hurry up. And we have done, and so far we have done only monies. Okay, so let's see what's going to happen when doing non-monies. All right.